initially and no roads between them. However, every day a new road will be constructed and there will be total of m roads. A component is a group of cities where a road into city. Okay, this is a general component. After every day, your task is to find the number of components and the size of the largest component. What? The number of components. Okay, I think we will be taking every edge this time, and after adding this edge, how many components are there, and if there are no, among all the components, what is the maximum sized component? So let's see, we can solve it using DSU. Fine. So if I combine these two, so initially there are n components. On first day, if I add some edge, okay, I can say okay, okay, there is only one component and the size is 2. So if I add one edge, if it belongs to this one, if it belongs to this, so if by adding this edge it creates a, okay, it is being attached to this group only, existing group, I can say there is only one component and the size is 3, maximum size is 3. But if there is one edge that is being attached here, so if somehow, that means this edge, so for this edge we have two we have two child, right? We have two nodes. Okay, let's say u and v. So on kth day, let's say we are adding an edge between u and v. What do I need to find? If u and v, so after adding this as u and v, so if they are forming a cycle, if they are forming a cycle, or how to find if they are forming a cycle? Okay, find the parent of u, find the parent of v. Okay, so if the parents, so let's say the parent of u, what is the parent of u? Initially everyone's parent will be the same parent, right? So parent of u and parent of v. So initially everyone's parent will be the same node only. So let's say if u and v, so this is my component so far, and I want to add this edge, today on kth day. I just need to find, so maybe there is one more component also, one other component. So this is these two are the existing components. So what can be the cases if u and v? Oh, if u is belonging to this and v is belonging to this, they will combine. So number of components can increase as well as can decrease based on the edge we are adding. And max size, I think every time we unite two nodes, we find the parent, and then whichever size is increasing, we can keep track of maximum. Okay, that is good. The second one is we can find easily how many components are there, how to find. So if u and v, so initially I think there are n nodes, so there will be n components, right? So what is on first day, it should be on first day it should be 4 because there are 4 nodes or what. So n is 4. First 1 to n. First line contains integer nm, the number of cities and roads. A and B. Road is constructed in city of A and B. Okay, because 2 are combined, so there is only 1. There is only 2. Okay, so there is only, so all which are combined, 5, 1 and 2 is combined, so 1 2 is one group, 3 4 5 are separate groups. Okay, 3 4 5 are separate groups, 3 3 is combined, so 1 3 is combined. Then number of components will always keep on decreasing, right? Decreasing, or it might remain constant, or it might decrease, it will never increase. Yeah, so every time I add an edge, what is this? Every time I add an edge, I think let's code it. Second part is clear. First part is, every time I add an edge, I need to find what is the parent. So let's say, so this is the current, so there are 2 components and I want to add an edge. So if the edge belongs here, if the edge belongs to this 2 different components, then the number of components decrease, minus minus we can say. But if it belongs to same, that means parents are same, let's say same, number of component don't decrease. Okay, got it. Let's say, good. There are n cities in an m, 7 roads equals to integer n b. Okay, we can write it faster. We have to take the edge. Okay, every day. So initially the number of components we can say n, and what is the max size is 1 of any component. Write the parent. So we need to find the parent of node u. We can say return the parent of u is nothing but parent of u is u, then it is u. Otherwise find make the recursive call, find the parent of u. We need the parent vector. Okay, we need the parent vector. Max everyone's parent initially, we will mark it as same so that base case works, and we have to do this ranking also. The rank of every node is 1 because they are RNK. The parent is fine, parent of u is same. If it is same, u, otherwise find the parent of u. How to unite two nodes into u and p. Let's find the set s1 of the find of u, the parent, find the parent of u. Set s2 is find the parent of v. So if they are same, we can return. If they are not same, we find the rank. If rank of s1 is greater than rank of s2, that means s1 becomes parent, so parent of s2 becomes s1, and rank of s1 gets incremented by rank of s2, else parent of s1 is s2 and rank of S2 incremented by S1, rank of S1. Is it fine? So we find the parents of U and V. If they are equal, good, return. Otherwise find rank of S1. If it is greater than rank of S2, parent of S2 becomes S1 and rank of S1 increments. Otherwise rank is smaller, that means rank of S2 is greater than S2 becomes the parent and S2 size will increase. So every time we increase the size, let's add these two here. So every time we increase the size, we can say max size is nothing but max of its own size and rank of S1, similarly rank of S2, because these two are the nodes whose rank have increased. So max is fine. Let's read all the edges. X to Y is an edge. If the parent of X is equal to parent of Y, if they are equal, if they are not equal, we can increase our component, we can decrease our component. So if they are not equal, that means the component will decrease. If they are not equal, if the parents are not equal, that means we are combining these two components, so it will decrease by 1. Got it? As well as let's unite these two now, X and Y. So every time if it is equal, we don't unite, component remains same. So we need to print the number of components and what is the max size. Let's see. Segmentation fault. Find the parent of U. Parent of U is equal to U, then U. Otherwise, okay, we need to mark the parent of I is nothing but I only. 4 2 3 3 2 3 4 2 3 3 2 3. Okay, let's see. Got it.